We're going to cover sections 8.5 and 8.6 today. More properties on quadrilaterals. The ones we're going to talk about in 8.5 are trapezoids and kites. We're going to identify and use properties of trapezoids and kites in this section. So definition, a trapezoid is a quadrilateral with exactly one pair of parallel sides. So if I put that on the board, I've got the parallel sides. That's a trapezoid. The parallel sides of the trapezoids are bases. So this is a base, and this is a base. The trapezoid has two pairs of base angles. This is a pair of base angles, right? And this is so we could call these base 1, even though they're not the same. I'm not going to call them both base 1 because they're not. We don't know they're congruent. But just know that these two are a pair together, and then these two are what we call a pair. The top two are a pair, and the bottom two are a pair. Non-parallel sides of a trapezoid are called legs. So this is a leg, and that's a leg. The legs of a trapezoid, if they're congruent, then we have an isosceles trapezoid, right? So if these two were the same, it's an isosceles trapezoid. What do you think we know about the base angles then if these two legs are the same? What would we say about the pairs of base angles? Any ideas? Yeah, they're going to be the same. Then we can mark these congruent. If the legs are the same, and likewise the top two would be marked congruent. All right? Okay. All right. So there's a picture of what I've just drawn again. It's labeled as such. If these are marked, the sides are congruent, we have an isosceles trapezoid. Everybody have those drawn? Any questions? Okay. Some theorems about trapezoids. If a trapezoid is isosceles, then each pair of base angles is congruent. We talked about that, right? Each pair of base angles is congruent. So I would mark, if I were to mark this up, I would say this is congruent to that. And these two are congruent as well. Theorem 8.15. If a trapezoid has a pair of congruent base angles, then it's isosceles. It's just the opposite of this, okay? So now we know we have the congruent base angles. We need to show that they are the opposite sides are congruent. The next theorem. I'll give everybody a chance to draw the last one. The next theorem. A trapezoid is isosceles if and only if its diagonals are congruent. So, if this diagonal is congruent to that diagonal, those two are the same, then I can say these two sides are the same length. Now, this is a good true-false type question, because they may say, if the diagonals of the quadrilateral are congruent, it has to be a rectangle. Okay? And what would you answer to that? What would your answer be? True or false? It'd be false, because this is the other exception. Isosceles trapezoid also has congruent diagonals. Okay, so that's a question that's kind of common. Okay, so just an extra shape to remember on that characteristic. Okay, so here's an example. The stone arch above in the diagram is an isosceles trapezoid. Find K, M, and J. Okay, so let's find K first. What would K be and why? What would K be?
85.
Yeah, it'd be 85 because it's the other member of the pair of the congruent base angle, so that'd be 85, right? And then what would M be? What would M be? I'll give you a clue. We know what M is because these two lines right here, this line and this line, are parallel. So M, based off of what L is 85, what would we know M to be? Aaron, how'd you get that? Yes. These two, because these lines are parallel, these are consecutive interior angles, they sum to 180. So this angle and this angle would add up to 180. So I subtract 85 from 180, and I get this as 95. Any questions there? Okay. Definitions. A midsegment connects the midpoints of two segments. Here's a midsegment of a trapezoid, for example. It is a segment that connects the midsegment of the legs. So this point on the trapezoid and this point on the trapezoid is the midpoint of these sides. You can see from these congruent markings. It's a midpoint of each side. I connect those midpoints and I have a midsegment of a trapezoid. Questions? Midsegment theorem for trapezoids. The midsegment of a trapezoid is parallel to each base. So MN is the midsegment. We can see from these congruent markings that we're connecting the two midpoints. MN is the midsegment. It's going to be parallel to AB and parallel to DC. The other thing we know about the midsegment of a trapezoid is it is 1/2 the sum of the lengths of the legs of the bases. It's 1/2 the sum of AB plus DC. In other words, what is MN? related to A, B, and B, C. How's another way we could say that? I like to think of it this way better because it's easier to remember. What could we say M is of B and C? If it's 1/2 the length of the sum. Anybody? Okay. Think of it as the average. It's the average of A, B, and D, C. And we know to find the average, you add them together and divide by 2. It's the average of these two lengths. Everybody got it? All right. Let's put these into action. In the diagram, MN is the midsegment of the trapezoid PQRS. Find MN. How would I set it up? MN equals what? Let's plug in the numbers. MN equals to what? It's a division problem. What goes on the top? Kayla, what goes on the top?
Is it 12?
That's part of it. Devin? What would go on the top? MN. We're solving for MN. Not sure? Okay. Jacob?
12.
Not just 12. Kennedy?
12 plus 28.
Yes. 12 plus 28. We're finding the average of those two numbers, so what do I have to do? Divide by? Gage? Kayla?
Divide by 2.
Divide by 2. Right. 12 plus 28 divided by 2. So that's going to be 40 divided by 2, which is equal to 20. Any questions? All right. In a trapezoid, JKLM, J and M are right angles. JK equals 9. The length of the midsegment MP is 12. Sketch the trapezoid and find its midsegment. And find ML. Okay, sketch the, yeah. Okay, so if we sketch this, okay, we know J and M are right angles. So if we start with J, I would have a right angle there, right? And then as I go around, you go in order. We can go clockwise. J, this would be K. Well, let's see. If J and M are right angles, if it's got two right angles, okay, all right. So we'd have to do it this way. We'd have to put the K over here. So this is J. This is J, and then we'd have K this way. It's not a right angle. Otherwise, we'd have a rectangle. So there's K. Right? And then this would have, as we go around, this would have to be L because the order of the letters. And then your M would be here. These two are 90s. Okay, that's still a trapezoid because one side does not have right angles. It's not a rectangle. All right, so that's the first hurdle, is visualizing the picture and drawing it. Okay? So that's JKLM, and it tells us that JK is 9. JK is 9, the mid-segment, NP, so we can add that. This would be NP. NP is 12, right? We have to find ML. Let's call it X. Now, we're still using the same idea that MP is the average of ML and JK. We just have a different unknown. What equation could I set up to find ML? What equation could I use to set up to find ML? Yes.
Could you do the mid-segment when we plug in the variable in?
Mm-hmm.
So you would put 9 plus x, and then divided by 2
Mm-hmm.
equals 12.
Very good. That's right. So we're still doing the average of these two lines. So we add them together, divide by 2, but we know the answer. It's 12. We have to find x. So I solve that, so I'd multiply both sides by 2, and I'd get 9 plus x equals 24, right? And then solve for x. X equals 24 minus 9 would be 15. All right. Now, if you're uncomfortable with that, if that doesn't click with you, there's another way to think about this. And we've done this before with, let's see, midpoints. When we've done midpoints and we've had to find the other midpoint. Okay? The other way you can think of this is, what's the difference between 9 and 12? Difference between 9 and 12. Carly? 3. So this, from here to, so this difference is, let's put it in a different color. Okay, the difference between 9 and 12 is 3. So, if this is the mid-segment, what do you think the difference between 12 and x would be? 3. Right? So, plus 3, plus 3. So we just add whatever the difference is here, add it to the next one. 12 plus 3 is 15. Right? That's probably an easier way to think of it. Just find the difference between these two and add it to this one. Right? All right, any other questions? Okay, very good. If EG equals FG, is the trapezoid isosceles? Again, this is visualization. Okay? So EG equals FG. So let's draw a trapezoid. EFGH. So we would have G well, we just start by sketching one. So we have, let's sketch it this way. We've got E F G H. So EG is equal to FG. That's not possible. That would not be an isosceles trapezoid. It would have to be EF equals GH, right? EF equals GH, or FG is congruent to EH. So my answer to that would be no. That will not work. Okay, there's the picture. I think they want us to use this as the picture down here. All right. So we can ignore this figure. Let's ignore this. Let's refer to the picture down below. So we've got, again, EG would be this line, FG would be this line. If those are congruent, we don't know if that's an isosceles trapezoid. All right. Now, now they take the problem, if the measure of HEF equals 70, so let's label that. The measure of HEF is 70, this angle is 70, and FGH is 110, this is 110, is a trapezoid isosceles. Okay, this is a pretty high level problem. Okay, we have to add more information to the picture to answer this question. What do you think I need to do to determine if this is isosceles? What about angles if it's isosceles? What do we know about the angles? The base angles. Right. So, but we don't have the other angle. This is a pair of base angles. We don't know anything about F. Right? And this is the other pair. We don't know anything about H. Right? Can I find out what F and H are? How?
You subtract 70 from 180.
Right. These two would be supplementary. So we subtract 70 from 180. This would be 110. I subtract 110 from 180 here, and I get this as 70. Okay. All I really need is one pair. I don't have to find the other pair. I'd have enough just with both the 110s to know it's isosceles, but we go ahead and find the other two. Now, both pairs of base angles are congruent. So is it isosceles? Yes, it is isosceles. These two sides would be the same. Questions? All right. Kite. A kite is a quadrilateral that has two pairs of consecutive, that means they're next to each other, congruent sides. But the opposite sides are not congruent. So as we look at this shape, as I go around, these two are consecutive, they're congruent, and these two are consecutive, they're congruent, but these congruent sides are not the same as these congruent sides. If both pairs of congruent sides were congruent, what shape would we have? What shape would I have if both pairs of congruent sides, if the opposite sides were congruent in this picture? What shape would I have? All the sides would be congruent, right? Which that? All sides congruent. Which one is that? Anybody? You should know this. Rhombus, right. So that's the difference. So this is what a kite looks like. Any questions? Okay. Theorem about a kite. If a quadrilateral is a kite, then its diagonals are perpendicular. Makes a cross. Think of it as a cross. The diagonals are perpendicular if it's a kite. The next theorem. If a quadrilateral is a kite, then exactly one pair of opposite angles are congruent. One pair. So in this kite here, which pair do you think is congruent? The right and left or the top and bottom? Brandon?
Top and bottom.
The top and bottom are the same?
No, the bottom two.
Yes, these two. The right and left. Okay? These two would be congruent. The others are not. Right? If the other sides, if these two sides were congruent, okay, then what shape would I have? What could I call it? We're doing a little review here at the same time we're doing kite. What if the other pair of opposite sides were congruent, what could we call it? It would be a quadrilateral. We could go a step further and call it a parallelogram. Right. You done? Just put it on my desk. All right, so here, find angle D in the kite. What do you think I have to do to find angle D? First of all, think of it this way. This will help. We know D and F are both the same, right? D and F are X. Now, knowing that, what do I have to do to find X? What do I have to do to find X? Abby.
124 and X, are they supplementary?
No, because we don't have parallel lines. Go ahead, Kennedy.
Could you do 360 minus 124 minus 80? I didn't take that number and divide it by 2.
Yes, okay. Remember, quadrilateral, what does a quadrilateral add up to? 360. So you add all these together, you would take 124 plus X plus 80 plus X equals 360. Solve for X. Okay, so that would be 204 plus 2X equals 360, right? So 2X equals 156. So X equals, what's 156 divided by 2? Good. That's good. Mental math right there. 78. Any questions? No questions. Everybody have that written down? All right. Find the missing side lengths. How could we find the missing side lengths? We have diagonals. What do we know about the diagonals in a kite? They are what? What's their angle? They're perpendicular. Remember, it's a cross. They're perpendicular. All right, so knowing they are perpendicular, all these are right angles here, right? How could I find these sides? What would I use? Which theorem would I use? Okay, we'll take it a step further. This is now a triangle. We have to find this side. What would I do to do that? What kind of triangle do we have? Not isosceles. Right, we have a right triangle. What can I use to find the missing length in a right triangle? Pythagorean theorem. So we would do 3 squared plus 6 squared equals, we'll call this x squared. So that'd be 9 plus 36 equals x squared. So then x squared equals 45. And then we simplify the radical. So x squared, x equals the square root of 9 times 5. If we factor that, 9 is a perfect square, so I can bring it out as a 3. So x equals 3 radical 5. Right? Okay. Similarly, you could do the same thing with 3 and 9. Because of time, we're not going to go ahead and do that calculation, but I could do the Pythagorean theorem with 3 and 9 to find the other side, right? And then I know these two consecutive sides. If this is 3 radical 5, this would be 3 radical 5, and these two would be the same as well. 8.6. Identify special quadrilaterals. So this is a graphic organizer. Okay, you might want to go back and study it. We won't take a lot of time to go over this, but we've got the big family All these are quadrilaterals, right? Except, yeah, even the kite is a quadrilateral. All these are quadrilaterals. Okay? Then if I take these four, right, I have parallelograms. Well, this one I would say, no, this is just a quadrilateral. But these, from this grouping, one of the things I can break off is parallelograms. Right? And then from parallelograms, I can break it into either further. They can be rectangles or rhombuses. Not have to be. They could just be a parallelogram, but special parallelograms can be rectangles or rhombuses. And then we know that a square is both a rectangle and a rhombus. So that's one way we can break down the chart. Then we also have the trapezoid family, right? We've got trapezoids where both pairs of opposite sides aren't congruent, but one pair is congruent. And then we can break trapezoids down further into isosceles trapezoids. And then the third subfamily we can get from the overall family from quadrilaterals is kites. Right? I've got a kite. And that's it. You can't go any further than kite. Kite is kite. All right, so I'll let you fill that out in your notes. Everybody have it? Anybody still writing? Raise your hand if you need more time. Okay. So, example 1. Quadrilateral ABCD has at least one pair of opposite angles congruent. What quadrilaterals meet this condition? Let's list them all, even families and subfamilies. One pair of opposite sides congruent. What meets this condition? At least one pair. So it could have two pairs. Let's start out with which quadrilateral has just one pair of opposite sides congruent. Which one would that be? Right. So we can make our list. We can say kite is one. All right. Now, let's assume it just says at least one, so now we can say it has two pairs of opposite sides congruent. So could we say in a most general sense, what could it be? Opposite angles are congruent. Both pairs of opposite angles are congruent. What could that make it? All right, these are the things you have to memorize from the chapter. Two pairs of opposite sides congruent is a parallelogram in the most general sense. Okay? It's a parallelogram. If it's a parallelogram, what else could it be? No, that's too general. Quadrilateral doesn't necessarily have at least one pair of opposite angles congruent. If it's a parallelogram,
Could be a rectangle.
rectangle, what else?
Square.
Square
Or rhombus.
and rhombus. Right. Could be any of those. Any questions? All right. Example 2. What is the most specific name for this quadrilateral? So what do we know about this quadrilateral from the markings? What is it telling us? Taylor. What'd you say, Brandon?
The diagonals bisect.
The diagonals bisect each other. So what could this be? Just from that information, what could it be? Yes. Parallelogram, right? We know for sure it's a parallelogram. It possibly could be a square, rhombus. Let's see, the diagonals bisect. Yeah, in all these, it could be possibly a square, rhombus, or rectangle, but we don't know for sure. We don't have enough information. The only thing we have enough information is to say it's a parallelogram. All right, example 3. Is there enough information given in the diagram to show that quadrilateral PQRS is an isosceles trapezoid? Is there enough information? What do you think, Faith? What's your reasoning?
Yeah, there is.
Yes, there is, because why? What tells you that?
Degrees.
Yes, okay? There's 2 steps to it. First of all, because this is 74 and this is 106, they're supplementary. That tells us what? What does that tell us? It tells us these 2 sides are parallel, okay? So those 2 sides are parallel. That tells us it's a trapezoid. From that we know it's a trapezoid. The opposite sides are parallel, one pair. Now, okay, we know it's isosceles because it has one pair of base angles congruent. We don't have to have the set. We could find this to be 106, but we don't need to know that. All we need to know is 70. We have 74 and 74. All right. So that answer there would be yes. Any questions? All right. We don't have time. We won't do the guided practice. The answers on the guided practice, if you want to write them down real quick, are kite and trapezoid. All right, so that's it. That quiz is going to be 856 next time. That slide's not quite accurate, but that's the notes for today.